morning. Can we start? My name is Andreas Lymberis from the European Commission. We are going to start our first session on micro-nanotechnologies for pHealth. I'm very glad to be here. This is my fifth pHealth conference. I don't know how many of you have attended all of the five. Can you raise your hand? How many of you attended the five conferences? One? Danilo, I think. Few of you. So it means that there is a new blood every time. So this is a good sign. I would like to thank the organizing committee for organizing this session, for taking the responsibility to put this event in place, and for putting also in place this very good program. All the ingredients are here to have an excellent pHealth workshop. Thank you very much. This reminds me a little bit of the history about this. In 2003, we initiated in the Commission the wearable technology and the wearable health management systems. It was 2002 when I organized the first meeting for Smart Textile, and then the year after we selected the first projects. And I was looking for somebody to organize the conference, and then Danilo De Rossi was the first to organize this in Italy, in Lucca. Then we had the year after in Belfast, Eric McAdams. I don't know if he's here, Eric. He didn't arrive yet. Then George Kotrosios from CSCM in 2006 in Lucerne. George is not here yet. And then it was Nikos Maglaveras in Greece last year. And then you today. And I hope that the conference will fly in the future better and better, higher and higher. So what I'm going to present here very briefly is what is the rationale, what are the activities organized around micro, nano, bio convergence systems. And then you will see with the presentations very good examples, not only of technology, but of some concrete results. So micro, nano, bio systems is not fundamental research, it is really applied technology. So we're fully working in the heart of ICT, biotechnology, micro-nanotechnology, at the interface where we expect new generation technology opportunities to come up. And we're following the three axes of development, which is computerization, more data to process, new analysis, integrated bioinformatics, data management, and real-time processing. This is very important. Second axe of development, miniaturization, continuous miniaturization, more, that will allow us wearability, implementability, high volume and low cost production. This is extremely important. The third axe of development is molecularization. We are building devices, machines, and components at the molecular scale, so to increase functionality at the level of DNA, protein, and cell detection. And all this requires high interdisciplinarity, and also medical research and unprecedented possibilities can come up from this research. This is a rapidly growing market. Statistics and, let's say, some studies say that it will pass from 4 billion to 70 billion in 2015. These are just forecasts, but we have here the profile of a very rapidly growing market. The areas where we're focusing in this group are dealing with biosensors and lab-on-chip components and systems, smart micro-nano systems and other miniaturized systems on and inside the body, and also accompanying measures like business and driving forces, mass production, user needs, ethical and societal issues. This is the group that you will have examples today, concrete. One is dealing with components like sample preparation, microfluidics, DNA protein extraction detection, biomarkers, surface functionalization, mobilization and detection, all this, but most importantly, integration of all this into a system, and also miniaturization of systems for implantable technology, study on biocompatible materials, micro-nano fabrication, sensors, actuations, biorobotic functions. Many common issues addressed by these subgroups: You see here the numbers. It represents 110 million euros spent the last 4 years. Several challenges are addressed by this cluster. Multi-material integration, for example. Fluidic, microfluidic design and manufacture. How to converge different type of detection techniques, biochemical, mechanical, optical, etc. Ethics, it's a very important, biocompatibility and intellectual property rights. This group of projects was born by some call of proposals. This is the way we are working in the European Commission. One was on this call. So we started with the idea to push technology. It's true, this happened 4 years ago, to push the limits of integrated micro and nanosystems through research at the boundary of integration between different engineering and scientific disciplines like micro nanobio, ICT, silicon, non-silicon, nanochemistry, microfluidics. Integrated systems for point-of-care diagnosis, we had a call 4 years ago now, and autonomous miniaturized micro-robotic systems. And you will see examples, concrete examples in this session. And then another call that we have organized with NMP, it is a program on nanomaterials and processes, on biosensors specifically. So these projects are coming from these two call of proposals. From what concerns microsystems, we have moved from the last year definitely from integrated micro nanosystems, from smart and heterogeneous to smart integration and smart integrated systems, where we are mixing heterogeneous technologies, we are interfacing with organic molecules, and we go from technology to system and integration in smart products. This is the main idea of microsystems. And as I said, in this area, the Commission has funded 301 million euros for the 6th Framework Program, 2002-2006, and among those, 35% concern micro and nano bio-ICT. And we are supported in this vision, in this development, by the European Technology Platform on Smart System Integration, EPOS, and the working group MedTech, where from specific technologies, sensor imaging, data fusion therapy, we go up to integration of technologies into smart and robust systems, applying solutions and applications to reach the vision, assisted health checking, assisted therapy and therapy control, full functional substitution and rehabilitation, monitoring and control of external influences. This is the strategic research agenda of EPOS. You have the website here to reach these final systems for this vision. Let's see what we have done in FP6 very rapidly. So in this group, you have, as I said, research on biochips and arrays. You will see today an example on wearable biochemical sensing and what we can do with this. Danilo will present it. Research and development on micrototal analysis systems and lab-on-chip, lab-on-card. You will see today integrated microsystem for magnetic isolation analysis of single circulating tumor cells for oncology. In the area of body sensors inside and on the body, we have several big projects here. Mark Schur will present vector activities. You will see amazing development. And also neuroprobes with multifunctional microprobe array for cerebral applications. And of course, Healthy Aims, which has developed and now it is finishing. It is a 4-year project, very large initiative in the area of implant devices. Commission is promoting this area. We organize consultation meetings to bridge technological know-how, to identify relevant subtopics for collaboration, and to address issues that can be better addressed in a collaborative work like standardization, harmonization, and compliance with regulation, etc. The Commission is putting its finger here. It is the ring that is missing between product development and basic research. We are not basic research, we are collaborative research program, applied research, and we are taking the risk to put public money on these projects